everyone. Tonight we're going to learn about independent and dependent events. As I mentioned before, this is really the end of the probability half, although we'll see probability woven in, and then we work our way towards statistics. Okay? If you read directions carefully, then you notice this big red box that says, for this packet, I'm asking that you try to complete each question before watching the video. Okay, so if you haven't tried these questions, you need to stop this video, go back, try them on your own, and then come back to me when you're ready to review. Okay, here we go. Okay, so this says, suppose you spin the spinner shown below and toss a fair number cube. List the possible outcomes for the spinner. Okay, so that's just asking you what could happen. Okay, you could spin a red, blue, green, or yellow. List the possible outcomes for the number cube. Okay, you could get a 1, 2, 3, 4, 5, or 6. What is the probability that you spin a yellow on the spinner? Okay, well, there's 1 yellow out of 4 colors. What is the probability that you roll a 5 on the number cube? There's 1 5 out of 6 numbers. Okay, all of this should be review. You know this. Nothing crazy. Then it says, what is the probability that you spin a yellow and then roll a 5? Okay, so it's combining the two events. Okay, which if you remember, when you have more than one event, more than one thing happening, we call it a compound event, just like when we did tree diagrams. Okay. For this, okay, you could make a tree, but to make life easier, I've given you this little thought bubble. And means to multiply. Okay, so if we take the probability of yellow, okay, which was 1/4, and the probability of rolling a 5, which is 1/6, we can multiply to find the probability. So we have 1/4 times 1/6. I hope you remember how to multiply fractions. Top times top, bottom times bottom. 1 times 1 is 1. 4 times 6 is 24. Okay, so you have a 1 out of 24 chance that you would spin a yellow and roll a 5. Make sense? Jot down any questions you have. And then lastly, it says, if you spin a yellow on the spinner, does it affect what you roll on the number cube? Okay, and the answer is no. Okay, whatever you spin on the spinner is totally separate from what's happening on the number cube. Finish correcting your paper and then flip to the next page. On this page, it says, suppose you open a package of Skittles and you have the following: 5 yellow, 5 orange, 4 purple, 4 green, and 5 red as shown below. Okay, a lot of you have started picking up on the fact that before you even start solving, you should find your total, because we need that for probability. So when you added these up, hopefully you got 23 total Skittles. And then we want to know, what is the probability of randomly choosing an orange? Well, there were 5 orange out of 23 total. What is the probability of randomly choosing a green? There were 4 green out of 23 total. What is the probability that you randomly choose an orange Skittle, eat it, okay, now it's gone, and then randomly choose a green Skittle? Okay, so we know the probability of choosing orange was 5 out of 23, and nothing's changed there. But if you eat that orange Skittle, how many total Skittles are now left? And that's the trick. There's now only 22 Skittles, and of those 22, we still have 4 of them that are green. Just like on the last page, and means to multiply. 5 times 4 is 20, And 23 times 22 is 506. You're welcome to leave it like that, or you can reduce if you'd like. Either way, those are fine. So now this time, did eating the orange Skittle affect or change your odds of choosing green? And the answer is yes. Okay, if you're eating one, then now your total is different. Okay, and what if the first one you ate was green? That totally changes the probability of you picking another green Skittle. And we'll look at more of these tomorrow. Finish correcting your paper and then flip to the next page. So here are our definitions. An independent event is when one event does not affect the outcome of the second. And that's like example 1. If you spin a spinner, it has nothing to do with rolling a die. Those are two separate things, and they're never going to affect each other. A dependent event is when one event does affect the outcome of the other. Okay, so that's like example 2, where if you eat a Skittle, okay, it disappears, you've changed the total. Okay, and that's really, that's what's going to happen most of the time. Okay, your total number will change. Okay, I can't guarantee that, but most examples I've ever seen are like that. Okay, and if we do some practice here, you'll see what I mean. It says place an I next to the independent events and a D next to the dependent events. Okay, it says there are 5 marbles in the bag. You reach one, take it out, then you put it back and remove another marble. Okay, so did your total change when you picked the first one and put it back? Well, no. If you put it back, then your total number of marbles is still 5. So we would say that this is independent. Okay, if you toss a coin twice. If you toss a coin, okay, let's say it lands on heads for the first one, is that going to affect what happens when you flip it another time? No way. Okay, those are two totally separate things. So that's independent. Mrs. Steeler has 24 calculators in her room. True story. Each one is labeled with a number 1 through 24. First, Lauren borrows calculator number 7. Then Angelina comes in to borrow a calculator. Okay, so if Lauren's borrowing number 7, is that going to affect which calculator Angelina can choose? Yeah. Okay, we've changed the total. Instead of having 24 calculators in the room, okay, or 24 calculators available, there's now only 23. So we say that's dependent. You pick a card, replace it, okay, you put it back in the deck, and then you pick another. Did your total change? No. You put it back, so we call that independent. You are the captain of a team. Bubba, the other captain, picks a player, and then it's your turn. Well, if Bubba's already picked a player, then now there's one less person for you to choose. So the total roster, okay, the total number of people you're choosing from has changed. That's dependent. It is dark. You pick a sock. Okay, so you're rummaging through your drawer, you can't see anything, it's 5 a.m. Then you pick another one and you hope that it matches. Okay, well, if you've taken a sock out of your drawer, you now have a new total. Okay, you have one less sock than what you started with, so that's dependent. You spin a spinner, then you flip a coin. Two totally separate things. Okay, if you spin a red, that has nothing to do with whether or not you flip heads or tails. Okay, Mrs. Steeler has a set of colored pencils. There are 2 yellow, 2 red, 2 orange, 2 blue, 2 purple, 2 green, and 2 black pencils. Maddie randomly chooses a blue pencil, then Rachel randomly chooses a red. Well, if Maddie's taking a blue pencil, now Rachel has one less pencil to choose from. Instead of having 2 blue, there's only 1 blue left. So we call that dependent. Anne draws a colored toothpick from a jar. Sorry about the typo. Without replacing it. Okay, that means she's keeping it. She is not putting it back. She draws a second toothpick. Because she didn't put it back, she's changing the total. That's dependent. Seth picks a colored tile from a bag, replaces it. Okay, he's putting it back. Then he picks a second tile. Okay, by putting it back, you're keeping the total the same. So that is independent. Finish correcting your paper, jot down any questions you have, and we will talk tomorrow. Good night.